Okay, so everyone should be in by now. And from there, we can start homework review. All right, right over here. Can everyone see the homework?
Yes.
All right. So, start with number one. What does the inspect window do? Now, does anyone know what the inspect window actually does?
It changes the value.
Exactly. The inspect window is basically useful for like all of the actual values, rotation, movement. So it does not let you make a game object a child of another one. Does not let you see the errors of the game object, and it does not let you see all the game objects in the scene. So the answer should be D, none of the above. Number two, where do you test your game? Now, in the scene view, that's where you're basically placing everything for your game. That's where you're um, putting everything in advance. The project view, that's literally just all your files, folders, assets, all of that. So your answer should be C, the game view, because the game view is what happens whenever, if you go to Unity and you just like switch from scene view to game view, that's the one that shows you the view of the camera, which is the official game view. Well, yeah. So number three, what is the console window used for? Now, console window, console. If we remember what the console was when we were doing C sharp scripts, right? We know that it can't be used for fixing game objects. That is, huh? We know it can't be for making game objects. That's what the hierarchy is there for. So it has to be A for viewing errors. The console window is where you'll go if there's any errors. You can always click on the alert that will pop up in the bottom area of Unity. Now, number four, what can the inspect window not do? Now, does anyone know the answer to this one?
The inspect window, um, it's none of the above.
Exactly. It's none of the above. Because if you look at the inspect window, in the inspect window, you can add components. That's one of the main components of it. You can rename game objects. It's a possibility. Same thing in the hierarchy. I'm pretty sure if you just click on it, right click on it, choose okay. And see, yeah. Oh, okay. And see, you can change properties of game objects on that one. So your answer should be D, none of the above. Number five, how do you make a prefab? Does anyone remember this one?
I think you make a prefab by dragging a game object into a project window.
Yeah, that's correct. Basically what happens is when you drag your game object into the project window, it turns it into an asset and you can make as many of those as you want and they'll have the same values and components as the original. It wouldn't be A because that's just not right, and it wouldn't be C because that's just not right. So number six, how do you make a game object a child of another one? Now, using tags. No, you are not using tags to make things a child of another thing. Tags are basically just used as a way to order your things that you'll probably see later on for sure, maybe. B, use the inspect window. Okay. Um, if we remember what the inspect window does, it it shows us the values and allows us to add components. It doesn't allow us to actually like group together game objects and things like that. Your answer should be C. You drag the child object onto the parent object, and that object that's a child will become a child of that object. So like if you had a cube and a sphere, and you take the sphere and you drag it onto a cube, then that will become a child of the cube. So seven, how do you add a prefab into the scene? Does anyone know the answer to this one?
Drag it from the project window.
Yeah, that's right. Because the inspector, again, just your components, your values. C, your hierarchy. That's all the game objects you have in your scene. But A is the project window. Project window has all your assets. A prefab is one of those. So you just drag it in from the project window. Number 8, what is a scene not? Hmm. Well, let's look at it real quick. What is a scene not? A scene is a collection of game objects. You put in all your game objects to a scene. B, something that can be loaded. Yes, you can load in scenes as we went over last class. You can make multiple scenes and you have to load into each one individually. C, something that gives game objects functionality. And does this seem like something that the scene does?
No, it doesn't.
Exactly. So your answer should be C, because your scene holds everything. It doesn't do anything with it. Number 9, what can the scene view not do? Okay, well, let's look over here. Move game objects. Can it move game objects? Yeah. You have a gizmo that basically pops up whenever you click on an object, and you can move it around with those arrows. You can rotate game objects too. There's another gizmo for that. I'm pretty sure there's like a thing over here with different objects for or different options for what type of movement you want to do. C, look at the scene. It's called scene view. I'd hope you'd be able to look at the scene here. So your answer is D, disable game objects. Only place you can do that is the inspector. And number 10, where do you change the layer of the game object? Does anyone know what this one is?
Is it the
What'd you say?
inspector B? Is it B, the inspector?
Yeah, that's right. It's the inspector. Because again, the inspector is where you can actually manipulate like all the values of your like object, and that includes what layer it's on, its tags, everything like that. Your hierarchy wouldn't work because again, it holds all your objects. It wouldn't be your project window because your project window is again where your assets are. It wouldn't be scene view because you're looking at the thing. You're not changing anything about it except for its like position and rotation, but not even exactly. So yeah, that should be all of homework. Does anyone have any questions? All right then, let's move on to our lecture. Give me a second. Okay, so let me share it right now. I got it up. And here we go. Can you guys see my screen with the C sharp?
Yeah.
All right. So just ignore the color scheme. That's like a customizable thing. You can do that in Visual Studio. So basically today we're going to be going over like actual code with Unity. Because last class we went over all of the Unity's like UI and things. Today we're going to be going over basically how to do things. So, as mentioned previously, to interact with Unity through code, you're basically you got to be making components in the in for your game objects. They're called script components in your inspector. It's like if you just go here real quick, right? I made one over here in the assets, but that's not like relevant right now. I'm just going to show you how. If you like you just make a cube, right? And let's just say your cube is Jimmy. Now Jimmy here is a really nice guy. We love Jimmy, and we want him to do something. And so you just click add component and you just type in script and then you click on that. And this one, the reason why it says new behavior script here is because I already made a script here. But if you noticed before, and like if I were to do this, you see how this says new script here? This is the one you'd click to create a new script. Just give it a name, maybe Jimmy, just Jimmy, create an ad. And when that happens, you have another script called Jimmy. Now, if we just open up this Jimmy script real quick, it takes a little bit for scripts to open up because when Unity goes to like the Visual Studio and stuff, it takes a while to get everything sorted. Um, so yeah. Now here. Now we have Jimmy.cs open. Let's just close down this extra script. And now we have Jimmy. Yay. We love Jimmy. Now that you have a actual script, we're going
I
to
have
be
a
going
question
over.
real quick.
Yeah, sure.
So how do you make Jimmy like a script again?
Okay, how do you make a script for Jimmy? All right.
Yeah.
Just give it a second. So it compiles. Basically, every time you go from Visual Studio to Unity after a change of some kind, it takes a little bit to load. I do not have the fastest computer, so I'm basically in the same boat as you guys are. Took me like 20 minutes to get this project loaded up, so yeah. But
What's
basically what you're gonna, yeah?
what's the component's name? Because there's a lot of different
Mhm.
script.
Okay, so let's go over that again. Let's just get rid of this one real quick. And we have Jimmy here, right? Well, here's how to get to Jimmy. You click add component, right? Everyone knows that bit. Now, you see that this one right here, the search bar,
Yeah.
just type in script. And you'll see you have a couple options. You have script machine and new script, right?
Yeah.
Or you might have different options. You want to click new script with the arrow. Now, when you click this button, it's going to bring you to a different window and ask you to name it. You can name it Jimmy. You can name it Jimmy is cool. You can name it whatever. And then after that, you just click create and add, and it makes another script for him.
Oh, so it just goes straight to Visual Studio. You don't have to create a project.
Yeah, basic. No, what happens is when you create a new script. So like let's say we have Timmy. Let's say we make a script called Timmy, and we create an ad. Now, what happens when you create Timmy is you have the script file here, and when you click on it, it should, or I don't know if you have to click on it specifically, but basically, if it doesn't open immediately, you just double click on that new script, and if it doesn't, or if it does open automatically, then it should just do this regardless, and your script will open up. So
Okay.
yeah,
But there's
all right, that's the Jimmy script, but so yeah, basically you'd have to double click on Timmy to open it up. You can double click on it, you can click on it and then choose open up here. You can also right click on it and choose open. There's different ways you can open it. Okay, so first things first, let us go over callbacks. Now, what are callbacks? Callbacks are basically things that Unity basically calls on to make your script run at certain points. So, for example, you have the start callback, which is called before the first frame update right here. It's basically called at the beginning of the game if your object is still there or when the object's created. So let's say you started the game and you had a character, right? So if your character was already in the scene, then this one would run immediately, and if not, and you created your character sometime later on, then it would run. This is what happens when your object is basically there. Update. Now this is called every frame. Every frame means like every single time your screen basically, or like, yeah, just every frame. If anyone knows what frames per second is, FPS, if you've heard that in terms of games, that's how many frames your game runs through to function per second. Now, there is a third option. Now, this one is called a fixed update. Now, what a fixed update does is it basically calls every physics update. It's called every physics update. Now, what a physics update is it's just like it says, a fixed update. It's a fixed like amount of frames per second, and it's called every single time that frame passes by. Fixed update is used more in terms of physics, and it's more It's not dependent on how fast or slow your game is, like update is here. Does everyone understand that so far?
Kinda.
Yeah. Because of how Unity accesses these, they don't have to be public. They can just like exist and nothing's really gonna happen with that. And so now let's go over outputting to the console. You guys remember the console from the before we got into Unity? Well, this one works a bit differently. So let's just let that exist right there. Let's go to void start real quick because we only wanted to go to the console once. And so how you're going to put a message into the console is because Unity has its own console, you have your own methods. So you have a couple different options really. You have debug.log, you have well, let me make sure that's right. Right. Bonk. There we go. You have debug.log, you have debug.log warning. And the reason why I'm putting empty quotes in here so that doesn't give me any type of squiggly line, because squiggly lines are usually not a good thing to look at. Sometimes you can ignore squiggly lines, but for now it's best to not. Okay, so these are our different ways to send messages to the console. You can also draw lines and stuff, but first let's just go over these. So let's just see what makes each one different, right? Let's say debug.log and let's give the message, hi, I'm Jimmy. We love Jimmy, so of course he's going to say hi to us. And log warning, let's say, I am cool. And let's say for log error, we say, Jimmy is happy. Now, you can do Control S to save. Another way you can save is, I'm pretty sure if you go to File, then you click save all. That's how you save. And now that you saved it, you notice if you go back to Unity, or if you just like minimize this, you'll see how it says like hold on busy. That's basically like reading everything new that's in the Jimmy script. And needs a second to just not die. Unity is a pretty intensive program, so it does take a
I have a
pretty decent
question about
computer.
it.
Yeah.
When I type debug.log warning,
Mm-hmm.
it says it's like a white screen.
It says it's what?
The characters are white. So like, can I share my
Oh no,
screen?
no, don't worry about the colors on mine.
No,
If you
like,
don't have the squiggly line, then you're fine.
oh, but like, let me show you. Let me show you. Can I share my
Yeah,
screen?
all right. Yeah. Because like my color scheme is just different because I changed it. Um, that's apologies on my part. But yeah, it's just
Share my
Can
if
screen.
you go back to the Unity screen so I can see?
the screen.
Wait, can I share my
I
screen
mean
to
the
show you real
Visual
quick?
Studio.
Oh, 1 second. What screen do you want me to share?
The Visual Studio. I just want to
All
do
right.
that.
Yeah, here are the different methods. Just ignore the colors that I have here because those are changed. Just focus on whether you have a squiggly line. If you have a squiggly line under them and you hover over it and it tells you like some type of error, that's how you know there's something wrong. If not, you're fine.
Like, can I share my screen to show you what issue I'm having?
Sure. Let's get your screen shared right now. If the host can give him sharing privileges.
Alright, this is my screen, so like the debug.log is like white.
Yeah, no. Like okay, here's what you're doing wrong. Do you notice the letter in debug, the first letter?
Yeah?
That's always going to be capital. Your issue is that it's lowercase.
Yeah, but it's
Your
still white.
No, but the color doesn't matter. If you don't have a squiggly line under it, you're fine.
Oh, I thought like when it's white, it's default, and so like it doesn't do anything.
Mm, I don't, no, I don't think so. I think that should be good. Yeah, I mean, because that's the function. I think it's just a visual thing. It will change maybe
I'm
if you
using
just
a
save it.
behavior script. Does that mean anything?
No, it doesn't mean anything. It's just a script that you created and you didn't name.
Oh,
Yeah, just that piece of code should work. So yeah, you're good.
wait, what's this one? Debug.error.
What do you mean?
Never
Let me
mind. I
just
know.
share my screen again. These are the three possible methods that you could use for like typing in a string to like the console. You have debug.log, debug.log warning, and debug.log error. So now let us see what happens if we run your code and let's see what Jimmy says. So let's just go to the console here real quick and then we just move this thing over here. And then let me just take a second for Unity to load and then click the start button. Now just ignore this color thing. This is a different thing that you can do to make sure that you know when your like game is started. This doesn't affect anything. You guys, I don't believe you guys will have this weird colored look. Again, it's just a visual customizability thing that I have on.
Wait, so after you finished coding, if you go into Unity, it just loads everything in?
It takes a while to load everything in, and then you'd have to manually start to see any of that code like be executed.
Um, it isn't showing that it's loading anything in for me.
Then maybe it's already loaded in. Because after it's finished loading, it just kind of like this thing just kind of goes away. So yeah.
Oh, now
So
it's
here we go. And if we look here, we have hi, I'm Jimmy. Hi, I'm Jimmy. That's our debug.log. I am cool. That's debug.log warning. If you see that, that different look. And if you look here and we select this tab too, Jimmy is happy. That's our error. So how debug.log works is just a regular message. Hey, warning is if you want to like if you want to yourself log a possible warning, you choose warning instead so that it gives you this little triangle. And if you look here, like this is off by like default, but you can always just click it back on. And then it gives you your errors. You can yourself log an error by saying debug.log error. And here are the examples of what those methods actually do. And you can just click that so that it goes back to normal.
Where do you
And
find the console again?
where do you find the console? Oh, right here. You see the
Yeah.
project window? The
Yeah, but
console
there's
tab is
no
right next to it.
there's no console on my end.
um,
Oh, okay. In that case, you're gonna want to go to, I believe it is if my Unity will stop like dying right now. Sorry. Yeah, I need my Unity is like lagging right now. It's not.
I have the console. Let me show you.
Well, if you don't have a console, I'm going to show you how to open up a console real quick. Or if not, no, if you run it with your code, as long as your game object's in here, like as long as your game object's like in the scene, you should be fine. It should work. But
what?
if the console doesn't show up after running it, you just go to Window, Panels, and I'm pretty sure you just click one console, and there you go. If it doesn't have a console, I'm pretty sure it opens it up. So Window, Panels, and console should be an option there that you can click on.
For some reason it shows there's more than 999 messages.
Did you put your okay, so did you put your thing in update instead of start?
What update?
Okay, if you look here, you notice how we went over the callbacks start, update, and fixed update? Well, update happens every frame, meaning it happens again and again and again and again. Meaning, what you probably did was you took this bit of code that we put in start here, which only calls once, and you put it in the update method.
But I
So what
didn't.
that's
It's in the start.
is it in the
Wait,
start?
Yeah.
I'm trying to get the
Hmm.
console to appear, but it's like not appearing. Can I show you on my screen?
Sure. Real quick though, can we look at what's going on with Dunvish's side?
Huh?
So also just for each one, all of the messages, it says there are two audio listeners in this scene. Please ensure there's exactly one audio listener. What's an audio listener supposed to mean?
An audio listener. I'm not familiar with that. Oh, if you go to your camera, do you have like two audio listener components on it or something? Or do you have two like cameras or main cameras?
I have something called audio listener on. Oh yeah, I have two main cameras.
Y-
I have
Yeah,
two.
just
I
get
have.
rid of one of them.
Okay, I'll just delete it.
And Nate, what's your issue?
Yeah, so I can't find my console window.
Yeah.
There's no console.
Go to window, like in the top. No, the window, just the if you see how it says file edit assets, right? Click window. Now click on panels, go to panels, and click
What?
console. Uh, did it not open? All right. So, did you have your script on any of your objects?
Yeah,
Which objects it on?
I'm using new behavior script.
No, but what, you know how we made the script a component, right, of an object?
Yeah, this is not a component. It's just a script.
Okay, then what you're gonna want to do is you're going to just make a cube object, right? A cube game object, right? Then you're going to want to go to the inspector window after you click on it, go to add component, type in script, and then choose new behavior script. You don't have to do new script because you already have a script. No, you don't have to create. Okay. If you want to create one, that's fine, but you already have a script that does everything, so you don't really need to.
So I made a script for the cube.
You didn't need that script. You could have just chose new behavior script. So if you go back to cube,
Yeah, I don't really need behavior script anymore. Then
no, fair enough. Yeah, you can delete it. And then just like double click to open up your script component. And now that you
yeah,
have Scrippy
no.
open, you can just like in your start, you can type in the like log, the debug dot log and that stuff. Like just debug dot log and then type in whatever message you want. Exactly. Semicolon, then save. You can just save it from there. You don't have to do anything else because
Okay.
we just want to make sure that console like pops up. So you can just do
Yeah.
Control S
Control
should
C.
save it. There you go. Item
I
saved. Now minimize your window. That little minus thing
have
in
you
your thing.
run it? Have you run it?
Yeah,
There's no.
that's what we're gonna show you. No, you don't choose those ones. Don't touch those. Just click down there. It's gonna compile over everything. And once it's done, then I'll tell you what to do to get it running. Again, you don't have to click any of those. You're fine. Now, you see that play button, the top middle,
The play button.
like the sideways triangle, the top of your window.
Which one?
No, top middle, top middle.
It's
The
being
middle of
blocked
your
by this. Oh, yeah.
you right there. Click that. Give it a second to load. And when it runs, you should have your console pop up if it hasn't. Okay. Here's what's gonna happen. So just click that play button again.
Okay.
If it doesn't show up, what you're gonna do is you see that project window that you have?
Yes.
Now, if you go all the way to like the far right corner of it, don't create anything. Just go to the far right upper corner of it, of that project window. You notice how there's a line between it and the inspector right there. You see that three dot?
Yeah.
Click on that. Click on add tab and
Add.
add tab
Add.
and then go to, is it not there? All right. Then let me see which one it is on. If it's not on any of them, then we should be able to figure out sooner. Hmm. All right. I think we should get on with the lecture notes. I'll help you like on break or after. Because I'm a little bit confused myself. But yeah, is that okay?
Okay.
Yeah.
So
So
stop
let me go back.
sharing.
Yeah. Let's go back to my thing real quick. Screen two. All right. So let me just now that we went over the debug stuff, those ones are more for just like you putting stuff into the console. They're not really that important unless you want to make sure you can figure out where your error is and any like big pieces of code. So you don't have to worry as much about those at all. Now, we are going to be going into the next part, which is vectors. Now, you don't need to know a lot of math about game development, but you do need to know certain things. One of those things are vectors. Now, vectors have different meanings and like depending on which like field you're in, like math or physics. But basically in computers, they're just a list of numbers. They're just a list of numbers. Unity has two-dimensional and three-dimensional vectors to represent position and like direction. Basically just saying like they can either hold two numbers or three numbers. And they're structs, so you basically use them like any other class. And so before we get into that though, let's launch a pop quiz real quick. All right. Time's up for the poll. So the correct answer is start. If you look at my screen share, right, you notice how it says here start is called before the first frame update. Start is only called once. Update is called again and again, and fixed update, same thing, just at a more like at a constant rate. Update depends on your computer's ability to run the game, basically. So your answer should be start. For people who said on enable, I don't believe on enables here. On enable isn't a possible option. So yeah. So yeah, your correct answer should be start. Okay. So let's move on to vectors. So, as you said before, vectors are just a list of numbers. 2D vectors only take two values, 3D vectors only take three, and you use them for basically position and direction or direction of like the object. So basically if you wanted to create a vector, like in start, for example, let's just say vector. And real quick, you'll notice that from what you see on my screen, there are, well, if I just type this again, yeah. you'll see there are different types of vectors. You have vector 2, vector 3, vector 4. We'll only go into 2 and 3 right now. So let's just make a vector 3 because we're in 3D. And let's name it, how about just Jimmy position? Because we want to know where Jimmy is. And let's say that's equal to. And now what you do is, when you're making a vector, because it's basically like a class, you have to like instantiate it. You have to do new vector 3, and then in parentheses, you have to type in the 3 numbers, like 2, 3, or 2, 4, 5, like that. This is how you create a proper vector. It's same thing works for vector 2. If you do vector 2, let's say Jimmy exists. Like just for like, even though that's not really what you name it, let's just say it is. And let's just do new vector 2 in here. And now you'd have like 2 and 4. These are how you create your vectors. And so there are different types of like static vectors you can use. What that means is they're like default vector, vector values. Sorry, default vector values that you can use. Now, examples of this is, let's just say instead of wanting this, right? We wanted Jimmy to be at like 0, 0, 0. You do vector 3 dot 0. Vector 3 dot 0 is the same thing as saying new, or it's the same thing as saying new vector 3 at 0, 0, 0. These do the same thing. Now, if you were to do this again, vector 3, or let's say we wanted a different one. Let's say we wanted this number to be 1, right? Now, if you wanted to do that, instead of vector 3 dot 0, you do vector 3 dot right. And when you do vector 3 dot right, this becomes 1. There's all types of different default vectors. There's vector 3 dot 1, which basically does the same thing as 0, except everything's 1 instead of 0. So if you do vector 3 dot 1, you'll notice that it will just be 1, 1, 1. If you wanted to
Oh,
do
so
vector,
vectors control like the position or like
they can, yeah. They're just a list of numbers, but you can use them for position and rotation. Or
yeah,
or
but
no,
then what does
position and direction.
vector Jimmy exist do?
Oh, no, that's just an example of how to do a vector 2. It's just, I'm just trying to show you that's the same thing, regardless of vector 3s and vector 2s. You can get rid of that real quick. It's just an example for vector 2s. The same thing, just only 2 values here. But
Where'd
yeah,
you
if you
get the
just
Unity messages your references from?
message, what?
Below the update is called once per frame.
Oh, that, don't worry about that. That's nothing really. Those are just like, I don't know why that shows up in my thing. I think I have my stuff configured differently, meaning like I have add-ons and stuff. You don't have to worry about all that though. That's nothing big. As long as you understand the code methods, you'll be fine. Just ignore like what like my thing looks like and focus more on what I'm actually typing in. Okay? So, vector 3 GV position is equal to vector 3 dot 1. And so basically there's other ones, like for example, you have vector 3 dot down, for example, right? And vector 3 dot down would have a value of like 0, I think it's -1, then 0. So yeah, there's different default versions of vector 3. If you want to find each one, you can just like search up Unity vector 3 like static variables or default variables, and it will show you. And you can also add vectors together. You can like do vector 3 dot down plus vector 3 dot like 1, for example. That's something you can do. You can also multiply them and like subtract, divide, all that works. So that is possible. Um and because we're like doing three-dimensional stuff, you don't really have to use vector 2. Vector 2 is only if you have like 2D projects, really. It's not really that useful. And basically, in order to do like any like math function or like a math operation, in Unity. Like that's not the basic plus minus stuff like that. You do mathf dot. Do mathf dot. And you can see here you have a lot of different options. You have like round, if anyone knows what rounding is, which I'm pretty sure every one of you does know what rounding is. You have all of these different ones like logarithms. You have like a lot of different stuff that's like way out of our zone. You have like exponentials. You have the trig functions like arcsine, arctan, arccosine, absolute value, things like that. You also have pi here. If you do mathf.pi, that's basically the value of pi. It wouldn't work in a vector 3 though, because vector 3 is a list of 3 things. So you probably need to make a new vector 3 for that. But basically, there is the most useful version of that, which is mathf.clamp. Now, when you have mathf.clamp, what this one does is if you just hover over it, it gives you like the definition. And if it doesn't on your end, then we'll just read it on mine. It says clamps the given value between the given minimum float and maximum floats, returns the given value if it is within the minimum and maximum range. What that means is it basically float results between the minimum and maximum weight. Yeah, clamp just like clamps your value or between the two values. All right. More method. Does anyone understand so far?
I have another question about the position. So like,
Yeah.
so if you do mathf.pi and
hmm
then like put Jimmy at a certain position, what happened in like the scene view if you put mathf.pi?
Well, first of all, there's an error here because it's a vector 3. It has to be a list of 3 numbers, meaning in order to do this, if you couldn't just do mathf.pi, you'd have to do new vector 3, and then you'd have to have one of them be mathf.pi or all of them be mathf.pi, really. Mathf.pi, mathf.pi. So like, let's say we wanted all of them to be mathf.pi, right?
Yeah.
What happens is when we run this, nothing happens. Because we have a vector 3 that is for Jimmy's position, but this doesn't change Jimmy's position yet. And that is actually a good segue into what we're doing next. Because our next thing is about interacting with your game objects. After you've made a vector 3 for Jimmy's position, you can change his position. You can do transform dot position. Transform dot position is equal to Jimmy position. There you go. What this does is it says, hey, transform basically the all the values of Jimmy's position and like all of that, and you want specifically that position. So you want to specifically change his position. And then you just set it equal to this vector 3 we have for his position. You don't have to do it this way. You could also just like get rid of Jimmy position. Oh, 1 second. Anyway, you can also do here new vector 3 like that. You just copy paste that right in here, and you don't need Jimmy position anymore. This is a valid way to change the position. You are literally setting his position into a value. So this would change his x value to mathf.pi, changes y value to pi, changes z value to pi. Now,
Wait,
if
so
we were to run,
you can also do Jimmy.scale or like the Jimmy scale to make it bigger and smaller.
let's see here. Do we have a local? Yeah, you have scale. You have you have transform.scale. You have transform dot, pretty sure you have transform dot rotation. You have a lot of different things at your arsenal when it comes to transform that you can search up in the documentation. There's a lot. For now, I'm pretty sure we're just going to go over transform, right? And so an example of something you could do with transform, other than this one, of course, is by, let's just say you had like, you have your transform dot position, right? And let's say you wanted to change it, but you didn't want to set it to a specific thing. You wanted to make it build off of itself, meaning you wanted it to go from one place to another and from that place to another. You wanted to keep going. In that case, what you do is you have to go out of the start because if you want it to keep moving, you don't want it to be in start, right? Start only moves once. So you'd be in update. and you do transform dot position, and let's say it's plus equals, how about 1 second? All right, let me just type this out, and then we're gonna go on a pop quiz after that. So just do like vector3 dot up. All right, it's time for a pop quiz. We'll go back into this in a second. It's not 1. Reason why is because we have to create a new vector3 with that value. The second one isn't right because you have to have a type vector3. Vector3 is basically a type of variable. So you can't just have a name and then set it equal to a variable or set it equal to a vector. It's not 4 because where's the vector part of it? That doesn't work out. So your answer should be the third option. Vector3 vec is equal to new vector3 x, y, and z. Yeah. Any questions on the pop quiz?
So is the answer to the pop quiz, number 3?
Yeah, the answer is number 3. Vector3 vec is equal to new vector3 x, y, z. Okay. So now here we are back to our movement. Update means you're being called every frame, meaning it's going to happen continuously. And we have your transform dot position plus equals vector3 dot up. Now, what we want to do here is we want to multiply it by time dot delta time. Now, what is time dot delta time? If you look here, the interval in seconds from the last frame to the current one. Meaning it's basically looking at the time it takes between one frame to another one and giving you how much time it takes for that. And the reason we multiply vector3 dot up by that is to make sure that your movement is as consistent as can be. It basically makes sure that no matter it makes sure that even if the frame changes, it still keeps the movement going as consistent as possible without being jarringly different based off of frame rate. If you had 30 frames per second and 60 frames per second, time dot delta time would try to make it so that it would look the same regardless of the. If you used fixed update, because it only goes at a certain frame per second rate, this one would be jarringly different, and things would start getting wacky based off regarding your frame rate. Things would start skipping around things. So time dot delta time is really helpful for keeping our movement consistent. So transform dot position plus equals vector3 dot up times time dot delta time. So again, what this does is it takes your position, right? And it basically adds on to your position. It says, hey, here's your position. I want it to go more in this direction because that's what vector3 dot up is. And then it keeps doing that again and again. Now,
I have a question. What's
yeah,
that little object that's between up and time?
that's your multiplication. When you multiply, remember you use star. You don't use X.
It's
Shift 8. Shift 8 is how
my
you get that symbol.
my thing is fully white, but even though the time on yours is a different color.
Yeah, like I said, you don't have to worry about the color as long as the actual
Yeah,
methods
but
and
so for me, it's red, right? For you, for me, it's red. Wait, let
do
me
you have
just
a
show you
squiggly
one.
line anywhere? Or?
I don't know, but you have a different color than default color. If you were me, like
Yeah, the color isn't what matters here. It's just the lines of code. So
isn't
yeah, if you
time
just
supposed to be a different color?
no, it's fine. Like I said, the color doesn't matter here. My color is different than your guys's because I just have a different scheme for it. But long story short, the color isn't what matters here. It's the actual code.
Oh,
So
so I
what
can't
you
run
type,
it.
You can't run it?
Yeah.
Like in the Unity?
No, it can't run it. I have to do a hard reload.
Okay, so when it comes to running scripts, you don't run them by themselves. You have to save them, and then after it compiles in Unity, you run it in Unity.
I saved it, and then what do I do?
Well, and then you just like go back to Unity and then wait for it to compile. Then you do that. So if I
I
just real
know
quickly,
it's
if
done compiling.
okay, and then you just run it how we ran it before with that play button.
I saved it, compiled it, and it still says hot reload, and I can't run.
I need to see your screen then. Okay, where's the error?
No error. I saved it, and I wait for the thing to compile.
Hmm. And then you just like like run it.
But when I can't run it still, even after I compiled it, it doesn't run. It's just hot.
Don't click into your scene. Don't click into your scene. Just stop moving in your scene. Move your cursor up to the run button. Remember that triangle that we clicked? And then see how it's going up? That means it's
Yeah.
working.
Oh, the
That's
script.
yeah, the script's working. That's your cube going up and up and up and up and up, like our script wanted it to. See that?
Oh,
That's what we programmed. That's literally what we just did. It's just kind of existing right there. So yeah, I was gonna run it and show you guys, but Nate here gave us the perfect example to look at it. It's kind of goofy. It's just kind of floating out there, but yeah, that's basically it.
okay. So how do I
You
bring it back?
just like instead of doing all that, don't do any of that. Don't do any of that. You see that play button that we hit? Just like click on it
Yeah.
again and it resets everything.
Um. Wow, that was
Yeah.
funny.
Yeah,
Oh wow.
that's basically how you run it and see what happens. Okay. So now let's share my screen again. And we're going to go to the next method that we can possibly do. That method is go right here, GameObject.find. Now, what does GameObject.find do? Well, GameObject.find is basically going to find a game object that has any name that you type in here. So if you just say GameObject.find Jimmy, that's going to find Jimmy. Because our script's already on Jimmy, it doesn't matter. But let's say you had another object, right? Let's say we had another object and let's make him a sphere because spheres are kind of cool, right? And let's name him Timmy. Now this is where Timmy comes in. Timmy's back, yay! Just drag that, put it over there. Timmy has a script now. Now let's just move Timmy a little bit away, like maybe just like anywhere really, like right there. That's where Timmy exists now. Timmy's kind of lonely. Now we have two different game objects. That's sad. It's not sad, I'm joking. But it just means that now if you do GameObject.find Timmy, what it's gonna do is it's gonna return you, it's gonna return to you that game object. Meaning you can make like game object like variables that represent a actual game object. So our game object Jimmy right now, he's a game object. It's a type of game object. So when you're doing game object.find Timmy, you're taking the game object, it's like details, and you can change anything in it, like transform. If you do like game object.find Timmy, you do transform, right? And let's say we wanted to change his position. Ignore toString, that's different. Position, right? Let's say we wanted plus equals like one, or not one. This is new vector 3, and then 1, 1, 1. What that does is it's gonna make Timmy go out. Timmy's gonna go out. That's basically what that does. If you were to put that in here, but first there's an issue with this line, and if you have noticed it already, props to you. It's because we have two semicolons right there. You do that, And what this does is it takes Timmy. It says, hey, where's Timmy at? We want Timmy. Finds Timmy, says, okay, what are we going to do with Timmy now? Looks at his position, and that says, hey, we're going to make you move too, bro. And if you run it, Timmy should also be moving. If you made Timmy. Timmy's like a sphere, right? Yeah, Timmy's a sphere that we just made and put somewhere else.
Then
While
so
it's
how do you make
compiling,
Timmy? Then how do you make Timmy move to Jimmy?
do you want to make Timmy move to Jimmy?
Yeah.
That gets into more complex like coding. I'll show you that after class if you want, but right now let's just focus on the task at hand. Um, another method that you could possibly do, another method is game object dot find with tag. Now, tags. If you were to go over here and you see Jimmy, right? In your inspector, right under that you have a tag. There's a couple tags that Unity already has by itself, but you can choose any of these and you can create your own tags. And so what that means is if I were to give Jimmy the tag of player, or no, let's say we give Timmy the tag of player, because Timmy's special. We love Timmy. Timmy gets to be the player. What that means is go game object, find with tag, type in player. You have to make sure that the spelling of your tag and the find with tag, like in here, the string of that tag is the same. You see how this has like a I'm pretty sure that's I'm pretty sure that's the proper way to type in player, but like let's just say I did player like this, right? And then we went back here and you clicked on Timmy. You notice how that's capital and how that's like lowercase? That wouldn't work. That would give you error, 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 error. You suck. Well, I don't think it give you error. I think it just like not return anything. But anyway, this is how you do it. Find with tag player. We know Timmy's the player, right? So if you did that, it's the same thing as before. You can access its transform and you can do a lot with it. Like game object and you can do like other stuff. But that's like getting into more advanced stuff. And so yeah, those are the two different things you can do to access and modify external objects. Now, I believe. Mm, yeah, no, there's more.
Wait, so
Yeah.
what if you want like the Jimmy to go up like at your own pace, not just time delta time?
Well, no, because time.delta time ensures that your own pace is the proper pace. What that
Yeah, but
means
what if you
is
want
that
the pace to be faster?
oh well then you just like increase your values in your vector. So you see how this is vector 3 dot up, right? You can just multiply that by like 10 and then it just goes 10 times faster.
Oh,
Yeah, the values in the vector is what's really like determining where it goes. Now, let's do a pop quiz real quick. So, correct answer is vector times vector. This gets into math with vectors. So how that works is you can multiply a vector by a number because that basically takes that number and multiplies everything in that vector by that number. Vector times vector doesn't work because those are two different lists. What are you going to do with that? You can add vectors because you're saying, hey, vector, vector, add their values together. So like, let's say, basically the three values, you have X, Y, and Z, and you have X, Y, and Z. It adds your X's together, your Y's together, and your Z's together. Z's. And vector divided by number works because vector divided by number is just vector times a number or vector times one over that number. It's just reciprocal. So yeah, that's how that works. Um, so there is some more that we have to go over. We have components. Remember how we added components for the script? Well, you do the same thing here. You can say, for example, like game object dot find with tag, or not find with tag. And because Timmy's a player, let's just say player. Now we have Timmy. Let's say we want get component. What does get component do, you may ask? Well, get component basically takes that component from Timmy of a certain type, or like in this case, that would be like pretty sure that would just be Timmy. Of type Timmy and returns it. Now, what does of type Timmy mean? Well, let's go back here. If you go back here, you notice how Timmy has a script called Timmy? That's what it's doing. It's Jimmy is saying, "Hey, Timmy, I kind of like your script. I want to take it real quick." And it just kind of like accesses Timmy's script. Now you have an object that you can, or now you have a component of Timmy's that you can like get something from. So like if you wanted to get like certain variables from it, if there were stuff like that, you could. And that's what components do. Like let's say you want to get component, and this is getting into like the physics thing. You do like rigid bodies and stuff like that. Then it would get the other players or other characters or other like models component, and that's basically what get components do. And you can basically access like the variables that they give you in that other script to use. Um, and then if you go into user input, for example, user input Unity is pretty easy. They're all in the input class, and there's like a few functions that we need to really like understand like how user input comes in. So for example, if you had like well, usually you can't just type these by themselves. You have to have an if statement. Because how these work is these things return Boolean values based off of the current action being had. So if you have like input dot, then you have input. Input is our blanket class, and you have different options in it. You have get key, right? You have get key, and inside of it is a key code. Now, what a key code is it's a specific name that the computer has assigned to that. When it comes to Unity, you can do like this one, and then do dot, and then type in like whichever one. So like keycode.v returns the keycode of V. So when you press the button V, you're gonna do whatever's in this if statement. Because it's an update, it's always gonna ask. If you do that in start, it's only gonna ask once and once only. And I assure you, I don't think you'll ever hit that in the first frame. So whenever you're finding user input, it's always best to do it in like an update function or a fixed update one for the sake of being able to actually read that input. And so what this would do is if you like click the button V, then let's say you want to bring you want to make Jimmy ascend to heaven or wherever. You just want him to go to space. If you want Jimmy to go to space, you press the button V. Now what this does is when you press the button V, it goes to space. There's also what happens for input.getKey is this happens while the button's down. So as it's like if you hold it, it's gonna keep going and going, and then when you let go, it's gonna go away. Now, what get key down is, or a different version, get key down. What get key down does is it only returns true on the frame that the key is pressed. So that's when you want to press it. Like if you just want to press that button, when that button's pressed, here's what you're gonna do. Because if you use the get key for doing that, it would do it again and again, while in the couple of milliseconds that you pressed it. So get key down is if you want a single thing to happen when you press something once. Get key up, which is the opposite of get key down, happens is basically the same thing, just when you release it. When you release it, you want something to do once. Key code, this thing is useful for all the different keys. You have like W, you have like pretty sure it's left alt, you have all of these different options. And pretty sure you also have N, space, for example. You have all that at your disposal. Um, and you also have the same thing with your mouse. Instead of input.getKey, you could do like input.getMouse button down, like get mouse button. And what this does is while you're holding your mouse, it keeps doing it's the same thing as the keys. Get mouse button down does the same thing. It's like if I were to do get mouse button down, I was to just do like, key code dot E, right? It's gonna like while you're pressing that, or not key code, my bad. You just do like get mouse button down, and Let's just look here, in button. Let's just say like 1, 0, 3. Okay, so here's a special thing with mouse buttons. When you have mouse buttons, you have different values for each thing. So if you want to left click, that's going to be 0. Right click's 1, and middle click's like 3. Middle click is that scroll wheel that you have here. I have a gaming mouse, so I do kind of have like different like buttons here, but that doesn't matter. This here is my left click. Just this is my left click. This is going to be 0. This here is my right click. That's 1. And this is 3. So if I wanted to do my left click, then I'd want it to be if I wanted to press it once, that'd be when I press once with my left click, you're going to make it go up. If I just did get mouse button, that's just going to be like in the like milliseconds while I pressed it down, it's going to keep going and going. And then up after you release it. After you get out of a press, that's what you're going to do.
I
Now,
have another question.
yeah.
How do you make it so that like when you press it, like when you hold it, after you are done holding it, it just stays in the spot like where it stayed after you released your hand from the keyboard or
So you
mouse?
wanted to go back to where it was originally?
No, like I want it to stay where it is.
Oh, no, because what this is doing is it's only moving it as long as you're holding this button down, right? How I have it coded. If you're like, and you just get rid of the up here, if you're holding your left click, right? It's going to keep going up and up and up. And then when you let go, it's going to stop because the if statement doesn't work anymore. Timmy's still going to keep moving because he doesn't go that way, but Jimmy, he's going to stop because he's a nice guy. Does that make sense?
Yeah.
Um, so there's a different type of input too for finding out mouse position. Um, this one's called input. Input dot get axis. And what get axis is it gets the axis or like the x and y of the in specific of that mouse. But you'd have to type in specifically like mouse X, or that's news. You need mouse X or mouse Y to get the horizontal and vertical mouse axis. And basically what the mouse axis is just how much the mouse moved since the last frame. So if you see my mouse here, right? If it's moving like this, your mouse axis is how much it moves between each like second or millisecond, basically. It's like if I'm moving left to right like this, it's gonna take each an individual move, and it's gonna be like, hey, what's the change in between it? And then it's gonna give it to you. If you did mouse Y, same thing, just up and down.
So how do you make a
And
child? Like how do you remove a child from a parent again?
how do you remove a child from a parent? Okay, well, let's say Timmy and Jimmy are child and parent, right?
Yeah.
Just like drag it out.
Yeah, but when I try, it doesn't work. I drag like Cube up to my main camera because it's
Hmm.
that way, and then it just doesn't work. I'm using left click, but I use
You have to click and
oh
hold, and then you just if you notice there'll be lines that pop up to stay out of it. All right. And yeah, that's how you get the position or like the change of position of your mouse. Next up, we have serialization. Now, if you want to access variables from your inspector, you need to use serialization. Serialization is the way to go. Now, one way to like already like just like use like variables in a inspector, for example, so you just like go here and you had a like public int and then you just say number, right? Let's just say it's equal to 0, or just public int number. Now, what this does is if I just like save it real quick, all this code's gonna compile, so it's gonna take a little bit, but you'll notice that when this is done and we click on Jimmy, you notice how there's no thing here. Like there's nothing here for like us to change the variable, even though it's public. Well, what serialized fields do is they let you change that. And how you do serialized field is over here. You just do brackets. You do serialized field. And let's say you had a private int number, right? What this does is even though this number is private, if I save it real quick and I go back here, see how that number's just there? It exists now. Serialized field is the recommended way to use like the to actually see it publicly to be able to change it. If you see here, I'm changing number. Wow. And so when you change number here, it basically changes the actual value of the one in here. Um, this one here, since we didn't give it a value, just defaults to 0, but we can change that value in the inspector. And the thing is the value in the inspector that you use here is the value that the code's going to end up using. Like regardless of if you have a specific value in the code, and I'm pretty sure it's just like because of how Unity works. I'm sure there's a workaround. I just don't remember it at this moment. And yeah, this is how you basically get the different objects and stuff like that. So like for example, say we wanted to get Timmy, right? We just wanted Timmy to be friends. Be like CLI friend, game object, and we just say Timmy, right? Now we want Timmy. If we save here, we go to Unity, give it a second to load. And if you click on him, now we can choose Timmy. Look, now Timmy's friends with Jimmy. And that's how serialized field work. Um and yeah, if you need to like put in a game object, you can just like click on that circle over there and choose one or take one from here and just go wee and drag it in there. All right. In that case, I believe we should start a pop quiz. So which is the proper way to get to find a game object by name? The answer is game object.find that name. It's not hierarchy.find. It's not game object.get, and it's not game object.look. So yeah, for the people that got those, you might want to look at the code a bit right here. And yeah. Pretty sure we will be moving on to classwork now. And so before that though, let's do another pop quiz. Number 1 is wrong. Let me show you why. You have here, it's just like that just says get key down, right? If you do, it's for is currently pushed down, get key down. Then you do key code. That's capital dot and then whatever it is, or just key code. Yeah, it's not input dot key, it's not input dot get key. It's not input dot is key down, it's input dot yeah, it's input dot get key. Key code. It's not input dot get key down because get key down, remember it only returns it the instant it's down. It's for presses only, not for like while it's pushed down. So yeah.
Okay, let's get started with the classwork. So, share your screen.
1 second. Let's get this going. Oh.
Okay, so for the first question, you have to make a script that outputs start to the console whenever the game object is created. So I'll give you guys around 3 minutes to solve this one. Okay, since we're running out of time, let's go over the solution for this. So if we can go to Unity. So for this one, we just have to output start when the game object is created, right? So the game object, the first method that gets called when the game object is created is start. So we can. So then for this one, you just do debug.log start in the void start. And that will print start whenever the game object is initialized at first. Okay. Let's move on to the next question. Okay, so for this one, you have to output the time it takes to load the last frame. And yeah, I'll give you guys 3 minutes to solve this. Okay, let's go over the solution for this. So since we want to output the time it takes for the last frame, we would go to the update because that function is called every time the frame updates. So we will just do debug.log time.delta time, which will print the difference in time from the last frame to this frame. Okay, let's move on to question number 3. Okay, let's go over the solution. So since we want it to we want it to print every time it updates, we'll go to the update method. So we'll check if the button is pressed down first of all. So if input.get mouse button down 0, we're doing 0 because it's a left click. And then if that's true, then we just write debug.log click. Okay. If nobody has any questions, we can move on to question number 4. Okay, so let's go over the solution. So since this is asking to set a tag, we'll go to the start because we only need to do it once. So let's start with game object A equals game object of find game object with tag because we want to find the object, and then main camera without space because tag is, yeah. And then if if A is not equal to null, then we set the main camera dot transfer dot position equals vector 3.0 because we wanted to set it to 0, 0, 0, 0, which is given by vector 3.0. And yeah, you could have declared a vector with 0, 0, 0, but it'll just take another line of code, but it's better to just use the variables initialized. Okay. So since we're out of time, we won't be able to go over the rest of classwork, but I will post it in the chat as bonus questions so you guys can try this at home. And if you guys have any questions, we can go over it in next class.